Welcome everyone. Today we're going to be doing lesson 1.6 done quick, and 1.6 is essentially algebraic manipulation of limits. Fancy term for we're not going to look at graphs, we're not going to look at tables, we're just going to look at the algebra. So some limits are easy. This is an easy limit. What makes it easy? Well, we're not breaking math anywhere. This function exists everywhere in its domain. So if I plug in 2 times 2 plus 1, I'm not breaking math. There's no problems here. 2 times 2 plus 1 is just 5, and therefore this limit is 5. Because the value exists, we're not breaking math. We have no weirdness. There's no division by 0. There's no asymptotes, no weirdness whatsoever. So if you can, you pretty much always want to start out with direct substitution. If you can. If it doesn't break math, doesn't cause any problems, then that's your go-to method. And if you're not sure whether it breaks maths or anything like that, refer back to your baseline knowledge from pre-calculus. We talked about functions for the entirety of our time together. And that knowledge is important. You can make decisions like this based off of that knowledge. Now, let's mess this function up a little bit. Let's multiply the numerator of the function by x minus 2, and let's multiply the denominator by x minus 2 as well. Now we have problems. Because if I directly substitute, we said that this part here, this factor, would make 5. This factor would make 0, which inherently in itself wouldn't be a problem. It would just mean that the function would be approaching 0. But if we look at the denominator, that's where we have this problem. We end up with 0 over 0. And when we have limits, and we have something like this 0 over 0, or we get something weird like infinity over infinity, we call this the indeterminate form. That is very fancy math terms for we can do something with this. And in this case, you can kind of tell, well, Mr. Whaley, we have a rational function with a common factor in the numerator and denominator. Don't those cancel out to make a whole? And they do. This function can be manipulated to be 2x plus 1 with the condition that x cannot be equal to 2. But just because the value doesn't exist doesn't mean we can't evaluate the limit. As we've done previously in prior lessons, at this point we have the same exact limit that we did at the very beginning of the video. 2 times 2 plus 1. Well, this function also approaches 5, but we wouldn't get that through direct substitution. We would need to factor and then cancel out the common factors. So that is algebraic manipulation. There are a couple of weird cases, and I want to talk about those because they may throw you off. So what if we have the limit as x approaches 1, and then we have something weird like x over x minus 1? Well, we can't really do anything with that. We can't eliminate anything. We would get 1 over 0. So this limit just doesn't exist. And that's okay. We may also end up with some weirdness. And the weirdness can really happen when we start to talk about trig functions. So here are some things that you're going to want to memorize. My suggestion, make some note cards. The first one, limit as x approaches 0. These special ones are for 0 of sine evaluated at a times x over b times x. This limit will become a over b. Now the cool thing is, it also works as its reciprocal. So if we have the limit as x approaches 0 of b times x over the sine of a times x, that will be evaluated to be b over a. Now this only works when x approaches 0 and we have this kind of setup. We also have something similar with cosine. Again, if we approach 0 and we have 1 minus cosine of anything, we're just going to put x for now, over x, this will approach 0. Now because 1 minus cosine approaches 0, this is also true if we reverse it. So if we have cosine of x minus 1 over x, that will also approach 0, because negative 0 is still 0. So I hope that helps. If you have any questions, let me know. This is a hard one. It's going to take some practice for some people, and that's okay. Good luck, and I'll see you in the next video.